In this video, we're going to take a look at Boyle's law. So what does Boyle's law say? Well, Boyle's law says that when temperature is held constant, there is an inverse relationship that exists between pressure and volume. And you notice we've got pressure in kPa and volume in decimeters cubed or liters. So what does this mean? Well, if we were to graph pressure versus volume, we get this kind of curve here. So at high pressures, we have low volume, or at low pressures, we have high volume. And if we were to take a graph of pressure versus 1 over volume, we would then get a straight line. So we can represent this relationship mathematically by saying P1 V1 is equal to P2 V2. And so we can calculate, if we know initial conditions of pressure and volume, we can calculate either the final pressure or the final volume or some sort of variation of this kind of question. So let's look at an example. We have a sample of helium gas that's collected at room temperature in a 4.50 decimeter cubed or liter, a balloon at standard atmospheric pressure. So remember, that means we're at 100 kPa. The balloon is then submerged in a tub of water, also at room temperature, so temperature is remaining constant, such that the pressure is increased to 110 kPa. What will be the final volume? So let's begin by listing out what we know. Well, we know our initial pressure is at standard atmospheric pressure, so that's 100 kPa. We know that our initial volume here is 4.50 decimeters cubed, or I'm just going to put it in liters. We also know that our final pressure, or P2, is 110.2 kPa, and we're trying to find our final volume. So setting up our equation, P1 V1 is equal to P2 V2, and plugging in all of our numbers, we've got 100, we got 4.50, 110.2, and V2. And solving for V2 gives us 4.08 liters, or decimeters cubed. We can double check and make sure that makes sense because we know an inverse relationship exists. So pressure is going up, which means you would expect the volume to go down, and that is slightly less than 4.50 liters, so that makes sense for our scenario. That's it for this video. Let's move on to our next task.